Thank you all for your time today. I want to try and make this as interactive as possible. So if you've got any sort of questions as and when they arise, you can use the Q&A panel. Hopefully you can all see that in Teams and you can ask any questions there. Hopefully if that happens, Emma can interrupt me mid-flow and we can ask any questions. And also related to the end, there'll be an opportunity to ask questions then as well. So thank you much for your time. To give a bit of information about Basemap. So Basemap, we're a company that was set up in the year 2000. So we've been working in the kind of transport accessibility or travel time analysis for 23 years now. We're very much experts in this field with over 700 customers in the UK or users of our TRACC software, as well as customers all over the world from New Zealand across to North America. And today we're going to be talking about our TRACC software predominantly and giving you a very quick kind of 40-minute kind of run through of all the features of how the software is utilised by our clients, ranging from people such as central governments, Department for Transport, down to local authorities, private industry, NHS, and so on. So TRACC itself is an application that comes in a few different flavors. I'll be demonstrating TRACC today on my desktop machine with a desktop license. We do offer licensing via concurrent and a server license, and we also have a version of TRACC called TRACC Web, which is accessible through a web browser. Today we'll do a bit of a deep dive into Sheffield as a city, and we'll be looking at how accessible the city is, looking at things such as 20-minute cities or 20-minute neighbourhoods to see how accessible it is to secondary schools. We're going to show some of the highlights of how TRACC has been used to power things like BSIPs by looking at adjusting the transportation network to improve access and improve the frequency of services. We have a bit of a look at different ways in which we can measure accessibility as well, using things such as public transport accessibility levels or PTALs, as well as local accessibility calculations. So, as you can see here, hopefully you can see the screen. I'm half looking at Emma to make sure we can see TRACC at the moment. She's giving me a nod, she is, which is great. So this is TRACC that we can see right now. It kind of works in a left to right manner at the top. It looks like an Office application. It uses the same kind of code in the background to look like a modern Office application. And at the top, you have different projects. And I've got a project here called Sheffield at the moment. So in Sheffield, the first thing I would do is load some public transport data. This data can be utilised from different sources. So some of you may have heard of BODS, the Bus Open Data Platform. We can load data from that. We can load data from the TNDS. Or what we can do as well is we can load data from our DataCutter tool, which is another product. I'm not going to talk too much about it, but this is a really easy way of accessing data. So here I'll just go Sheffield. Choose the public transport data, choose the quarter of data I'd like to get. So quarter 2 2023 is the most recent. Choose which modes I want, choose the output type and the result, and I can download that's in a TRACC ready format. We do the same for road data, public transport data we've spoken about, point of interest data showing where we've got, for example, secondary schools are located, and we can also use it as well to access demographic data as well. So once I've got that data, we use the import button to load that into TRACC, and it effectively looks something like this. What we can see on the map right now is a series of dots. The green dots represent where our bus stops are located, and the grey dots we can't really see very clearly. So we've got a grey scale background map on there as our tram locations, and the black dots are our National Rail locations. I can then go into any one of these stop locations just here. And all the data comes across, the timetable comes across, these routes come across as well, the stop locations come across, everything comes across. So here I've chosen at Barnsley Road, the unique NAPTAN code associated with that location. If I want to see service number 97, I can go into that, look at the outbound route, which then gives me a preview of the stopping pattern going from stand H4, so going from the centre north of Sheffield, all the way down to Baslow Road with a route length just over 20 kilometres. I can then see the timetable of this service. So I can see it's got Sunday service that leaves at 5 o'clock, 6 o'clock, and so on. So we can see all the service information within here. And I'll show us later on how this can be edited. And what we can also do is load in fare data. For those that are aware of BODS, or the Bus Open Data Platform, it was apparently mandatory that every bus company supplies their fares in a format called NetX by the end of last year. Unfortunately, that's not been hit, but with the has supplied, we can load the NetX data in here. So then we can show a fare triangle of how much it costs to travel between two different bus stop locations on the same route within TRACC as well. Once you've got public transport data in, we then load in road data. So our road data I've got in here at the moment is a data set called OS Highways, but we can load data from TomTom here. We can load an OpenStreetMap data. We can load various different formats. Once it sits in the application, as I zoom in, we'll see other layers will turn on. As I zoom in even closer, we should start seeing all of the one-way information appearing on the roads, so showing where it's a one-way link, or we can see information as well where we've got turn restrictions as well. So we've got banned turns, mandatory turns. All that information is also provided in the software. And on the roads, we have the stops on the roads. We have information as well that can be edited. They show things such as the type of road, the name of the road. For you that work in local authorities, the unique street reference number and the TOI DOS link ID is provided here. And we can load in data that gives speed at different times of the day. So here we can see on this roundabout in this location, in kilometres an hour, which I'm set up to be, the average speed in AM peak is 46 and evening is 49, so not much difference. And this will become important later on when we start modelling new transportation routes. This data also includes very detailed footpath information, which is great. Due to come out in highways in the next month or two is all the rural paths, but all the urban paths are in here. So we can see a very, very detailed network for routing through. The next thing we specify in TRACC is where we want a journey to start from. So think of TRACC as like doing lots of kind of Google Maps plans where you're going from A to B. This is doing that en masse. So in this example, we can set how many A's do we want. And this first example, what I'm going to do is get a grid of points that covers the whole of Sheffield. Let's just zoom out the layer. So what I've done here is I've loaded the boundary of Sheffield using the add by area shapefile function, specified I want to have a 250-metre grid of points that can basically fill the whole of that area in here. So it looks something like this. So I've got 5,882 different locations in total that I will now generate journey times from. The next question is, where are we going to? So again, using the DataCutter, I've downloaded all of the secondary schools that sit within the Sheffield district boundary. Sheffield's a great example because we've got a very, very dense urban environment just here with lots and lots of trams and buses and trains, all these wonderful transportation modes. But also to the west, we have a very, very rural setting, as you can see here, with no kind of school locations anywhere near it. There's a great example to show of how you can look at both urban and rural accessibility in the same way. So once we have our origins and we have our destinations and our transportation data, we can do a calculation within the software. The first one I'll be showing you today is called an origin destination. This is looking at doing journey times for every origin to every destination. So that's our 5,000 or so origin points to every one of our 30 different destinations or schools in this example. We're going to get 5 examples here. The first one we'll talk about is public transport and road network. This utilises both public transport data and road data to generate a journey time. And why this is important is many times we might see calculations that are done that only use public transport, and you see the circles of accessibility that come out. The issue with this pure crow flies methodology is it doesn't take into account rivers or buildings where you can and can't walk. As I mentioned previously, with really detailed footpath data, we want to utilise that when looking at access. So public transport and road network will use them footpaths and stop people walking on water. These bottom 3 modes here cover active travel, so walk only or cycle only, whilst the third option here is car, which can look at driving accessibility. You may also have noticed on them road links with an A speed and a B speed. So TRACC can model bi-directional speeds on roads as well. So going into a city centre might have terrible congestion, but going out of it may not. We can model that within our TRACC software. As we're using detailed timetable data, we can specify which public transport modes you want to use. We'll ignore guided busway for the moment. We can then choose which part of the timetable you want to look at. So, for example, I'm looking at access to a school, so it might be 7:45 to 8:45 in the morning. That effectively is giving me an hour's window in which I need to complete that journey. So I can't leave my origin points before 7:45, but I have to be at my school gate by 8:45 in the morning for the start of the school day. We can also on this screen here load in demand responsive transport services. So if we've created any demand responsive transport within the software, which I'm not going to cover in too much detail today, but you can reach out to have more information on that in the future. We can model that here just well. And if we want in rural areas only look at service that have a specific frequency within that time period, we can select up here. So if there was a bus service that ran once on a Thursday afternoon, that might skew the access. We can effectively say actually the minimum frequency that service must have is X per hour. And the final setting here is the direction. Lots of the time when people look at access, we're only worried about it getting to the destination. In this example, going to the school. But actually, the reality is you need to look at the inbound direction. Can they get home from school? It's all very well modelling access to getting to the school for 8:45 in the morning, but if they haven't got a bus that can get them home in the afternoon, then that's not a very good thing at all. So we can switch the calculation by doing an inbound. We can model 3:30 to 4:30 to model that return journey. This has been used quite a lot in car parking permit systems where we've modelled total journey time getting to a large employment site and home. Again, we've got a great case study on our website about that. So yeah, great look at that total value of access, not just in one direction. We've got some other settings here. I'm going to gloss over most of them, but I'll pick out a few that I think might be of interest. The first thing that is quite interesting is this internal connection distance. This allows someone to interchange. So in the detailedness of Sheffield, we've got trams, we've got trains, we've got buses. This will allow someone to get off a bus and walk 500 metres to get on a different service. It could be another bus service, it could be a tram, or it could be a train. We can also say what the minimum wait time is there. So if I was to get off a bus at 8:15 and then walk for 5 minutes to a tram station and get there just after, I'd have to have a minimum wait of 5 minutes to allow a bit of a buffer of that journey. That can be reduced to 1 minute if required. We will specify how far we want to walk at the start of that journey. So the maximum connection distance of first stop, this is their 2 kilometre walk. It's about a 25 minute walk in total. We've seen people reduce this down to be 400 metres in urban environments or leaving it default 2 kilometre. That can be done either or. And also here we can specify how many interchanges we want to allow the calculation to do. So what we mean here is, do you want to get direct service? So there'll be no interchanges, or are we happy for them to make unlimited? In this example here, I'm going to leave it as unlimited. All of these settings that come out of TRACC are used by Department for Transport and the National Journey Time Statistics. So they use the TRACC software. And so what we generally find is consultants and people like to leave these as the default because if it ever goes to public inquiry, because they also the same settings the DFT have utilised within the application. We then give our result set a name. We can choose a few options here. So we can save the path report. This will save every OD path as a separate CSV file. That'll give you the exact detail of when it got on the bus, which road links it walked through, and so on. I'll show an example of that later on. We can do a direct save to CSV to not return results back into TRACC. If you wanted to use it in a third-party piece of software or load it into SQL, we've seen people do directly. You could use that save as CSV to do a direct export. We then have the option to batch the runs, so save for future runs if you wanted to, or we can do an enhanced output. And again, this will give us more information, not just the journey time, but how much time was spent on each mode, how many interchanges were made, and so on. And again, I'll show that in a bit. I'll then go next. It'll give me a summary that show me in this example 176,460 calculations to be completed in total. This would probably take about 5 to 10 minutes on my laptop, so not a very powerful machine, but in kind of Blue Peter fashion. I'm not sure if everyone wants to get that reference, but here's one that I kind of prepared earlier on. So here I've got my public transport to all schools. I can double click on the result and show how I want to interrogate that. So I can do a contour, or I can do a thematic map. So a contour effectively joins all the dots together, interpolates where there's no result, and gives you a nice flowing result. Whilst a thematic map will just colour each one of those blue dots we saw a minute ago in via a different colour based on the criteria I set here. So if I'm interested in 30-minute access, I could do 3 ranges. I could do 10, 20, 30. I can then go OK, and effectively it looks something like this. I've got my name of public transport to all schools. I'm just going to turn my public transport stops off. Actually, no, I'll leave them on, but I'm going to move that to the bottom. So here we can see where we've got pockets of good accessibility kind of sitting in and around where our destinations, so our schools, are located. We also see where we've got pockets of good access. So here we've got our 30-minute bands coming out towards Low Bradfield, I think that is. And we can see where we've got access around the buses. And then we can see in more rural areas, such as around this location just here, we can then see where we've got no green dots representing there's no public transport stops in this location. So Gullies Wood just here. We've got poor access because they live a long way away from a road, which would be what's expected. And now what we can do with these results is we can export them out as an image using our Publish tool on our Home tab. Or what we can do is if you use GIS elsewhere, we can export that layer out as a shapefile. And then you can load that up into QGIS, Esri, MapInfo, anything like that, and it'll come across in exactly the same banding that's been done here. So we've got that great kind of interoperability with other software if required. So what else can we do? So this looks like, if I bring back the grid of points, let's just zoom out.
Dan, just while you're doing that, I don't know if you've seen the question that's coming from Kane. Are we able to answer that as we go on?
What is the question?
So is it possible to export the data out of TRACC in a GDB stroke? Is that shape for further manipulation in a GIS package?
Nice. So shape I showed a second ago, we can do that. We can also export the points out as a CSV file that are geo-referenced with an X and Y coordinates on that save as. Doesn't work with contours, but for point data, for the thematic map, we can save it as a CSV file. But we can't do it direct to a geodatabase or something like that. But a shape file is loved by GIS people everywhere. It's the most common kind of format, and at these sort of size of files, it doesn't make too much difference. We have had people plug directly into the SQL backend and utilize the data that way. So there's different ways which we can do it. So hopefully that answers the question. I think it did. I think I saw something flash up just then.
Thank you, Dan, and thank you, Kane, for the question.
So here we can see the area of Sheffield. We can now see within 30 minutes, actually, I'd say about 50% of that is kind of covered with a contour within 30 minutes. And we can see quite a vast area is not covered. So what we can do is actually start bringing in demographic data here and working out actually how many people can get to a school, how many 11 to 15-year-olds can get to a school. Our data at the moment. So it's a great baseline that we can look at to start looking at this. So what I've done is I've used the add button and added 11 to 15-year-old data. And then what I can do within this is I can do a demographic data report that shows me how many people between 20 and 30 minutes, aged between 11 to 15, what percentage of the total population of 11 to 15-year-olds can get to a school within 30 minutes. I'd go OK and run through, but I've got a result that I've already done just here and formatted. Now it's showing me that out of the whole of Sheffield, there is 27.55% of the population of 11 to 15-year-olds live within 10 minutes walk or public transport commute of a secondary school. We can then see up to 20 minutes, it jumps up to 87.65, and up to 30 minutes, it jumps up to 97.25. So depending on what your criteria is being set, you can then say, oh, okay, well, actually 97% is probably quite good, but you can start using that as a year-on-year comparison. And we'll talk about 20-minute cities. This is where this value can really start coming into play. So when we look at Sheffield as an example, we can start comparing different access. So here's a study we've done on Sheffield previously. This was done using pre-pandemic public transport data. So I thought it was useful to bring this back up again and compare secondary schools. This is our secondary school map pre-pandemic up to 20 minutes. And here we can see that actually the percentage was 90.98%. So actually we can see here now that actually when we compare previous and after, it's actually dropped by 2.5%. Now, could that be because the census data has changed slightly? We're using a different census data set between now and then, or is it because public transport has worsened and actually is now less availability of transport for school people to access at the locations? So that example, you could compare both of the shape files, both of the contours, and work out where that difference is. Emma, were you about to?
I was, yeah. Thank you, Dan, and thank you, Daniel, for your question. Dan, is waiting time perceived or actual at the first boarding stop included in this travel time metric?
So we follow the Google Maps mantra that effectively you turn up a minute before the departure time. So effectively you're turning up and there's no wait time there. Now we can, and we'll come across later on, do frequency reports where you can start calculating headway times if you wanted to and adding that on. So we can say the first stop, this is the stop that was located here, and this is the frequency of service to that stop. But we rely on the end user to add that to the total journey time in the CSV file. We did do a poll of our users if you wanted to include headway time previously, and it wasn't seen as important, but as we do believe in user-driven development of the software, but lots of the features we're showing here have been suggested by our users. If it's something that is seen as being important, we can do that.
Thank you, Dan. And just quickly, thank you, Lee. Dan, can you show the census data again of how to obtain it? You think the shared screen lost connection?
So on the census data, the easiest thing to do is use our DataCutter. There's a free tier on here. We're currently working on the 2021 in here at the moment, so I had to go to the NOMIS website to get it. But in the next few weeks, we'll have 2021 in DataCutter. But in here, you just go draw an area. You go census. I wanted, let's have a look. I wanted to get 11 to 15. Go find data. I see this as well. And effectively what this will do is it will download that data into a format of a shapefile and an Excel file. The Excel file's got the boundary information in it, and the shapefile's got that boundary, the stuff appended to it. And that data can be then directly loaded into TRACC using the census and the add button. There we can choose that Excel file and we can choose our shapefile, and it loads in nicely and sits in the application just here. We can load census data. We've loaded census data for Australia, New Zealand, North America. We use output area level generally in Great Britain, but we use census areas, I think they're called, or tracks in North America, and small areas, I think, or something like that we use in Australia. So yeah, that data could be utilised all over the place within TRACC. Okay, excellent. So that kind of shows us our base kind of line. What we could also do as well is, just to make it run a bit quicker, I'm going to do a bit more of a targeted approach and look at access just for destinations in the city centre. So what we can do here is if I change my destination now just to the schools in the city centre, and this will be our playground of where we're going to start looking at a bit more information within TRACC. So again, if we look at that same result, but only up to 30 minutes, just here, we can start seeing how access looks right now. What we can also do with these results as well is we can say, actually, here's our 6 schools in the city centre, but let's now look and say, I want to see just access to Oasis Academy, and I'm interested in maybe 20 minutes, so 10, 20. We can effectively choose one school or a selection of schools and look how 20-minute access looks like for a different individual school itself. Or what we can do is we can do a catchment. This really only works well if you've got up to 20 destinations, which is why I've lowered the number down. This is now showing me, I've got a couple of similar colours here. Let's randomize again. There's a couple of blues, at least. So what this effectively shows us now is which area do you live in is the closest destination for you to get to. So this lovely large area of kind of orange, UTC, Sheffield City Centre, is the closest one for you to get to, which is located just here. Here we can see in the dark green, UTC Sheffield Olympic Park actually has got quite a small catchment area. and we can see the pink one that sits in between. And the interesting thing here is where you've got these pockets of different colours that sit maybe geographically further away, but because you've got some great transport such as trams and National Rail that can get you from A to B much quicker, sometimes it's quicker to get to a destination that's actually further away than another one as the crow flies. This is why going back to straight lines isn't always the best way of modelling this. Using actual timetables and routes and footpaths is a much more accurate way of looking at access.
Dan, can I ask you a question, please? Thank you, Ed, for your question. So, Dan, can I test again, do something scenario, e.g., see what happens if a new road is built or PT timetables change?
Hold that thought. I'll come across that later on.
Thank you.
Yes, no problem at all. What we can also do as well is look at walking access. Again, we've got a great case study on our website that looks how Staffordshire use TRACC to promote modal shift to schools by doing walk zone maps inside new starters packs, and they basically showed it as a new starter. They promoted walking schools or park and stride, where you'd walk, I think it was 10 minutes away or park 10 minutes away from a primary school and stride back in. And this is exactly what they did. So they produced all the destinations. An example like this, they then produced contours showing this time walking. I've done it in 15 minutes, so 5, 10, 15 minutes away. And then what they use is they use the export contour per destination. And what that effectively did is for every one of them destinations, they exported a separate shapefile. So if you've got a workbench package in QGIS, you can automate that, pick up each one of those different destinations and automate the printing of the maps to show walk zone maps at every school. I had a couple of hundred schools, and actually the process was very, very quick using this automation within TRACC. So again, I really do urge you to look at the website of how that was utilised. So if I just remove these. So if we were to look at initial access just here, now what I'm going to do is do the what if scenario. So what if we decided that around Lodge Manor and Carsick Hill we wanted to improve access right now? How could we go about doing that? So we can model that very, very easily within TRACC. So on the PT network, we can create some brand new stops. So to do this, I can go to the stops tab. I can go new. And then what I can do is choose where I want the stop to be located and click on the map. You'll see it'll auto-populate the easting northing position to less than a millimetre accuracy. So this up to here is 1 metre and all this is less than a metre. So I don't know sure why we got to that kind of level, but we have a very accurate level of modelling it. I can give our stop a name, such as stop 1. I can give it a NAPTAN code if it's been assigned, or I can leave it blank. I can then go save, and that's my stop created. I can then go new, click on the next one to go, and go stop 2, and so on. And eventually I'll build up my kind of route, and they'll start appearing as these white kind of dots as unassigned stops on the map. The next thing I want to do is create a service. So here I can create a brand new service, call it V1, say the travel mode. So maybe I'm looking at a guided busway. Operator, which would be an operator code, it's 4 characters. I can then go save, and then eventually we'll have something that looks like this. So I've got my guided busway, and when I created it, I can then create a route. And to do this, I can add my stops. I go stop 1. I go stop 2. And so on. So I'll start building my route up so you start seeing the preview of where they're going. What I'm going to do is just going to copy this one. I think is that one. Yeah, perfect. So now I've got my route all set up. It's got my 8 different stop locations. What I can then do is I can actually change and generate a route line to show exactly where this route is going from and to. Can't really see it, but it's happening in the background as here. So now you can see our route line has been created. As we zoom in, we'll see now this route is picking up all our stops on the route. Actually, the distance has been updated here. We can then save this, or what we can do, if we wanted to, is you can save that route line out as a shapefile. So if you want to include that in the reports or anything like that, that could be done. We then create a timetable. If you know the timetable, you can just add a trip if you want to do it that way. But what I'm going to do is I'm going to use that lovely information I've got on the roads from the GPS to generate a trip time or timetable for me. So I'm going to say my first departure is at 7 o'clock in the morning. If I don't have a speed on that road link, I'm going to choose the default of, let's do 30 kilometers an hour. I'm going to take it to a school pickup service. It's going to spend 1 minute each stop. And what I want to do is I want to pull that timetable using the AM peak. So then it's going to tell me to do this route from start to finish, leaving at 7 o'clock to get to the destination. It's going to take 42 minutes in total to do this journey. I'm then going to edit it and say it runs Monday to Friday. It's a school-only service. And I'm going to say it's going to run from the 15th until the 22nd of May. Go OK. So that's now created and is ready to be utilised. What I can then do as well is I can highlight this and I can say this is going to run from 7:15, so I've got my 7 o'clock, until 8:15. And there's going to be 15 minutes between each trip. Go OK. And now you'll see it'll copy that information across to me at a frequency of 4 per hour. I've now got that journey in just here. And then what I could do is I want to do another one later in the day using the PM peak. I could utilise that if I wanted to. Or if you're adding 2 new stops in the middle of a route, you could do that. It appears 2 lines here. You can use a function like an Excel file and highlight and go add and say this is now going to take an extra 2 minutes. And if you watch this is 8:20, if I then go add, it adds 2 minutes to it. So you can really edit the data as you see fit. Or we can edit and delete trips to change the frequency of service just here. And if I then go save, it's then going to save that and then be utilised elsewhere as I want. That'll now be used when I do a calculation that I'll show in a moment. What we can also do as well is we can export that D1 service out as a AtcoSIF file or as a trans exchange. And for the users that know that what trans exchange, there's different schema versions. We have 2.1 and 2.5, the 2 main ones. So we can export out in either of those 2 formats if required. Or we can export the whole network out using the GTFS function, where we can export the whole network out as a GTFS file. So now what we can do is do another calculation. We'd run through it with our guided busway. We can then look at a result showing up to 30 minutes. We'll then go OK. And hopefully we're going to see along this section just here, we'll start seeing pockets of improved accessibility. So we can now see these areas here that previously were not accessible within 30 minutes are now accessible, which is great. What we can then do as well is we can use our census data, so before and after snapshot. So this is our before snapshot at the moment, showing up to an hour in total. So we're showing that previously, without the guided busway, 193,000 people, this is all people, not 11 to 15-year-olds, can get to a school within 20 minutes. After the guided busway, that goes up to 204,000, so an increase of 11,200. We can then see over 40 minutes, actually the increase is 1,125. And over an hour, the increase is only 281, which doesn't sound like a lot. And the reason why the increase is so low over the amounts is actually lots of these areas here were accessible within an hour. It's only these real pockets at the edge that now have improved access, which is why that number has changed. So again, we can do that for public transport. For roads, it's exactly the same kind of option. So we could, if I turn my rows just on here. I haven't got demonstration for this, but I know that it was asked. So on roads, we can effectively draw new links. So you could draw, so again, Staffordshire used when there's local sustainable transport funding. They looked at where the optimal location of a footbridge over a railway line would be, and they effectively did the same sort of thing here. So they draw the link, it snaps the detail, you'd say what type of road is being created, plus creating an alleyway, it auto-populates some of the information. And you then rerun through the calculation, and it will then show you, again, the change in the contour, and it would also show you using population data the change in that as well. What we can also do as well as part of this is we can find out which of our schools is the most accessible after the change. So again, using a census report that comes straight out of TRACC, we can look at our 30-minute access here. Here's the name of all of our 6 schools in the city centre. And I can do largest to smallest, and it shows me that UTC Sheffield City Centre, within 30 minutes, 301,000 people can access that. And then UTC is the least accessible, 72,000. And this has been used a lot for both positive things, working out where different COVID vaccination centres could be located, or when new cancer units should be placed in the NHS, or it's been used alternatively if you want to close a library down. Let's look at closing a library down that's the least accessible potentially, and see how that has a knock-on effect with access. Because these destinations aren't set in stone, you can add them or remove them within the application if required. The other thing we can do on the public transport editing side of things is just a great feature that was suggested by one of our clients, is a thing called the timetable editor. I can draw a route that I know is going to have some changes being made to it. Now that change could be a positive impact, such as I'm putting a bus lane in for this location just here, add the buffer a little bit, or it could be a negative impact where maybe we've got roadworks that are going into place or something like that. So I can use this timetable editor. I can say for a bus between Monday to Friday, maybe there's going to be roadworks between 9 o'clock and 1500. And now it's to take 5 minutes longer to get through that corridor and the rest of the route as well. I can then go next. It'll tell me all the services that are going to be affected by this. I can then choose to update them all if I wanted to show the positive 5 minutes. I can then go next. And it gives me a preview of what's going on. I've chosen a long route, so this might take a second to run through. But effectively,
Dan,
you can then get...
can I just ask, we've just had a couple of questions in just while that's running through. Thank you, Daniel, for your question. So Dan, is the bus route snapped onto the underlying highway links, or are the 2 layers independent?
So they're independent, but when I press that button in the route, it then snapped it. So you can do it as a straight line if you want to and not use the road network, or using that generate route line that effectively snapped it to the road network and use the real world distances between each of the locations and use the time associated with each of those links as well. So the AM peak, the PM peak, and so on.
Thank you. And Lindsay, thank you for your question. What is the source of the base journey time data?
So the base journey time data of timetables is coming from the operators generally. So BODS data is provided by the operators. It's the same data that powers the Travelline app, Google Maps, people like that. It's all the scheduled information. So that's where that comes from. The road data in this example, the GPS data that's showing the average speed has come from a company called TeleTrack Navman. It's freely available in the PSGA for any public funded organisation. It was added in April, so we're using the same data just there as well. Or we can load in again speed data from people like TomTom or Here or anyone like that that's got it appended in a shapefile.
Thank you, Dan. And one more. Thank you, John, for yours. So did I see early on that cycling and walking trips can be assessed in the same way? And what if cycle routes can be tested as for bus services?
Yes, certainly. So cycle can be done as part of it. So at the moment, we allow cycling on most roads that are applicable. We don't allow it on dual carriageways or motorways by default. So we can cycle on there. Now, the safe aspect is a really good question. So we've been speaking to Ordnance Survey, and what they have now is their national transport layer. And as part of that, they're going to be showing which road links have segregated cycling or not as part of it. So again, we can be able to load that in the future into TRACC to show actually where is cycling segregated or not. The other thing that users can do is they can edit the data. So you've got local knowledge. You could, for example, update, there's always a high street. I can update all my high streets as an example. If you need a name better, you could do that. And I could go to cycling and choose actually the high streets in Sheffield consists of a B roads, minor roads, A roads and local streets, and I actually decided that the A and B roads aren't safe to cycle on at all. So I can go 0 there and go finish, and that'll then update that network and not allow people to cycle on it. And we can do the same for walking. Interestingly, on walking, there's also some work going on in Ordnance Survey about light posts and are roads lit or not lit, and that's deemed to be safe or not safe for walking on. And again, when that data comes across, we can utilise that. Also in OSM, there's a flag in the data, which is a 1 or 0 for cycling and walking. And on import, we can choose to utilise that data. 1, I believe, meaning it can be cycled or walked on, and 0 being it can't. And we can utilise that within TRACC as well, if required.
Thank you. So we've just had a couple more come in. Thank you all for your interaction. Thank you, Ringo. Dan, can we export bus mileage statistics?
Yes, we can use the route lines that will give you the length of the string as part of it. So we can do it that way to show how many trips are done. We can do the frequency as well as the mileage, or it can be done via the back end if required and much quicker. We are working on enhancing that to allow the whole thing to be exported in one go, and that'll be something that will be coming out in a future release.
Thank you. And Ed, thank you for your question again. So when cycle mode was mentioned, Dan, is it weighted to favour safer routes, like cycle tracks instead of main roads, or consider gradient? And the second part of it is, sorry, a destination may only be within 20-minute accessible ride if a dangerous, busy road or steep hill is used.
Yeah, so on the gradient, so that's a really good point. So we have A to B and B to A speeds. So A to B, if I click on a link just here, A to B will effectively show speed in one direction and B to A being the other direction. And so what we've got clients that are doing on this data is adjusting the cycle speed and walk speed manually at the moment to show actually the gradient has an effect on cycling in one direction or not. Now, in the highways data, there is a XYZ value that will give that information, and we're looking at potentially utilising that, or there are some free point data for height that we may look at using in TRACC at the moment, but unfortunately that's a manual process right now. And also on the question around safe routes, I think I covered that a second ago. So at the moment there's nothing being done, but OS are working a lot on producing that as a data set, or you've got it in OSM.
Thank you. And Joe, thank you for your question. So how do you generate the census data after the new bus route has been created and the calculations done to compare with previous census data?
So in the census data, we're using it as a baseline, so we're not factoring in an increase in population at all. That can be done as we have the output area levels where we can adjust the raw data if we wanted to, or we've got people using mid-year estimates and things like that. So all we're doing is doing a like-for-like comparison. So there's no change in the population. Everyone lived as they were. The change is actually happening by the change in journey time, by putting an improved service or improved access. So because this area is now accessible, or vice versa, we've removed the subsidised service so it can go the other way, we can then use that baseline census data to compare the before and after snapshot of that.
Thank you. And Jim, thank you for joining us from overseas. So can you incorporate bike stress levels into the routing?
Not easily directly within TRACC. Again, we can, as part of our road network, we can update the speeds. So if you have modelled, so we've got people using transportation modelled road data, I guess the same would work for walking and cycling. If you've modelled something to say, actually there's a deterrence on this section of link or this interchange, and that will add XYZ time, which is all really deal with time or distance, you could do it that way. But it's not something that's done directly within TRACC. It needs to be done in a GIS and then imported into the system.
Thank you. And then finally, John, thank you for your question. Are off-road routes included on the base mapping for cycle and walking trips?
So that's a great question. So I know that Sustrans data has been loaded within TRACC directly. I know that local authorities have loaded public right-of-way network data into TRACC to do routing through as well as a data set, as a shapefile that can be loaded in. It all depends on the data and the data source. So I know that OpenStreetMap has got some of that data in there as well that can be loaded in. So we're data agnostic, we're a tool, and we rely on data to be loaded into the system. I know that OS are doing a lot of work on their rural tracks to load into TRACC or into their data set. So again, it's all on the data. If it exists, we can load it in effectively.
Thanks, Dan. Back to you.
Perfect. Okay, so after that call is done, you can rerun a calculation and work that out. But I'm going to skip through that result because we are getting a bit pushed for time. So next thing I'm going to do is show us effectively a more detailed view. So what I've done here is for my origins, I've loaded 481 different locations that are postcodes. And then for these postcodes, I'm doing exactly the same calculation again. So looking at access to all the 6 different destinations. And then this result is I'm going to do a thematic map showing up to 30 minutes. And so what this now does is it starts each of our postcodes in. We could use address points if we wanted to, but I think postcodes is a good level here based on journey time. Again, these randomized points are probably better for reports. So what we can do as well as this is we can export the data out as a CSV file. And what this effectively does, I use the enhanced output in this example just here, which gives us a report that looks like this. So here I've got all my metadata that I used to calculate the Tuesday 7:45 to 8:45, what modes of transport were utilised. And as I said at the very beginning, we work out every origin to every destination. So here I've got my 6 origin, well, so my 6 results from my 1 origin. So here's our postcode S11AA. I can then see the 6 different destinations they've gone to, and here's the name of our schools. I can then see the name of the school, the coordinates of it. So if you want to load that into a GIS, you could. I'll then show, is it walking or not walking? I can then show the journey time to each of the schools, not just the closest, but the 6 closest, and a breakdown of how much time was spent walking, how many interchanges were made, how much time was spent waiting, so no interchanges, no waiting here at all, and how much time was spent on each mode. So you can see all this lovely information here that's provided for all of our results. Let's just find one that's got an interchange. That's, and there we've got an interchange just here. We can actually see how much time was waiting between the services. So we can see the total wait time here was 4.28 minutes for these 2 postcodes to get to the destination as part of it. What we can also do with these results, which are great, we can also load back in the OD path file. So the OD path file shows us the exact journey that was undertaken. So here we'll see I've got lots and lots of different files. Each one of these files has got a naming convention of origin ID to destination ID. So if I choose 2 to 4 just here, and we'll load this back in like you would in a GIS. I'm then going to, I can directly save it to a shapefile. I'm not going to do that. I'm then going to style and make this nice and big. And here we can see where the school is located. I'm turning the roads off just to make it a bit clearer, and I'll turn these off. So I can see the exact journey from this origin to get to the school located over here. We also have a data view within TRACC where we can highlight the section of route, and it shows us each stop. So here I can see we walked for 3 minutes. We then got on the Cathedral South Yorkshire Supertram at 7:52 in the morning. Service number was YEL, so that's a yellow route. We stayed on here until 8:02, so we were there for 10 minutes on the journey. And then we walked to our destination, giving a total journey of 19.85. If I was interested in any section of this route, I can click on them on the map, and that highlights red, so we can see exactly where it steps through. I can double click on the end location, and it will then zoom into the location, show me where it got off the tram, how it walked over the bridge, then to get to the roads, each part of the road it's walked on, where it needs to cross over to get to the destination. And in the next release, we're actually doing a joined up link where these will actually produce a route line as opposed to a series of dots, and that'll be coming out hopefully next release in about a month or 2. I haven't put our product people under too much kind of pressure. So again, that gives that kind of transparency in the results. We're not just now getting the journey time, but we're getting the result of actually how can I do that journey? And we show all of that in the results just here for the users. What we can also do as well is using the enhanced output, it allows us to do a report called the service frequency. And this is something that we got asked about during COVID times, where people wanted to plot all the locations of where all of their staff members effectively live. And effectively, what we could then do is show which of the public transport services that are essential to be kept open to get our key workers to hospitals. So what they could do is locate all the addresses of all the staff and then put the locations just in. And this gives you a report that looks like this. So this is now for schools in the morning. These are the services that all of my S1 postcodes effectively would utilise. Here I can see that the most important service is service number 24 by FSYO as an operator. There's an FAC lookup that we can utilise for that. In the inbound direction was used 481 times in total, whilst the yellow tram service was used 434 times and so on. So then you can start doing start putting new services in here or removing services. You can see how this changes as part of it. So again, it's giving you kind of a ranking of the most important transport routes you need to maintain and keep open. So if you were subsidising the 120 as a local authority to get people to school in the mornings, actually you'd very quickly see that actually maybe you don't need to subsidise that anymore because it's not being utilised a lot to get people to school locations. So that is it for the main origin destination kind of calculations. We do have other calculations which we can do, which I am going to run through very quickly. The first thing we can do is a thing called a stop frequency. What this will do is show me on a Monday between 7:45 and 8:45 in the morning. It will show me where our high frequency bus corridors are through the network. I can look at stops with a combined stop frequency, so adding all the services that call there, or just individual. So let's look at combined stop frequency. I can then say, well, I want 4 bands. I want one is up to 1, 6 an hour, 12 an hour, and above. And again, this is now colouring all of my locations in based on frequency. I can then choose to thematically map these. So these are my 12 or greater. We've got a bus and these corridors are here appearing every 5 minutes or more frequent. So we can see that information. If you're doing a new housing development in a location just here, you can see you've already got a lot of buses, a lot of choices are going through it. And again, using our selection tool, we can highlight some of these stops. We can use the data view again to step through these locations and see, you know, for example, this one here, this stop has got 36 an hour, this has got 13 an hour, and so on. And then we can save these selections out as well if you wanted to, again, to a CSV or a shapefile. What we can also do, as well as you can take this one step further and do the local accessibility calculation. This is used a lot for planning. This is now changing the calculation type from using destinations to using public transport stops as a destination. So here, for example, I can find out all the locations in and around Sheffield on a Tuesday between 7 and 9, have at least 4 buses an hour calling at them, and are within 800 metres using the road network of the road. So you can run this through, it doesn't take too long. And here we've got one I prepared earlier on for 6 an hour. This has now been a result in meters. So I've been up to 800 meters. And what I can then do is produce an output. Anywhere in red is within 400 meters of a bus stop with at least 6 services per hour calling at it. And anywhere in blue is up to 800 meters. And these white areas, again, in these kind of more rural areas or central estates where you haven't got your main bus corridors, are showing that are outside of that area just here. So again, this is looking at kind of planning, NPCC kind of planning policy, where you have in urban areas between 400 meters of a bus stop. This is now telling you 400 areas of a bus stop, but this is also adding in the extra feature of frequency as well. So most people, when they do this, will choose 1 service an hour to look at that. And the other thing we can do, and the final thing I will show before we can go back to some questions, is a thing called PTAL. So PTAL stands for Public Transport Accessibility Level, and this takes us to the next level. This is predominantly used in London, but you've seen it used in other places. And what our PTAL calculation will do is it will generate a score, so an accessibility score as opposed to a time. And so we can choose our PTAL, we can choose modes of transport, we can choose reliability factor. These are set by Transport for London. Choose a day and time period and walk parameters. And again, we can set a result set off here. And then we can show what a PTAL looks like on a Tuesday between 7:45 and 8:45. And here what we're doing is we're showing a colour banding based on the access level. So London criteria stipulates that if you've got a 1A or a 1B or you're not covered, you've got poor access and no development can be done in that area. And then as the score goes up, effectively your PTAL rating gets better. And what this looks at is it looks at distance away from the public transport stop, how many stops are within that distance, and the frequency of services at all of those stop locations. So this is a really different kind of way of looking at access. So it doesn't care that if in the centre of Sheffield, can I get to a doctor's surgery or an employment centre or a school? All it's saying is I've got great access to transport and a great opportunity to access a network and other things. So again, this is a really quick way of getting a dirty overview of access across a city or a region, but using that origin destination calculation, we'll kind of tie that down and give you the actual values of access for walking, cycling, driving, public transport to schools and so on. And that in an hour is TRACC. Hopefully that's been useful. I really am up for more questions, but I know that people ran an hour booked in, so people need to jump off. I was keen to try and finish it and show all the features of an hour. But yeah, please, Emma, if there are any more questions that come in, I'm happy to answer them.
Yeah, absolutely. And thanks, Dan. Daniel, thanks for your question. So Dan, has anyone written speeds or junction delays from a highway model, e.g. Saturn, onto the TRACC road network? And is that practical?
Yeah, certainly. So we've seen people use Saturn and Vism models to generate future forecasted demand speeds. In that example, what they would then do is export it out of that model as a shapefile, or they'd use the underlying road network that we're into and export it as a CSV file with a link identifier in there, and you'd load that data in. So at the moment, the stuff that we've got from within TRACC is being modelled as actual speeds over the last 6 months. You can then use really detailed Vism Saturn models to do actually what's our 2030 model look like on our road network, our 2035 model. You can load that in and do very quick access levels as part of it. So yeah, we can do that, no problem at all.
Thank you. And Joe, thanks for your question again. So Dan, if one or more TRACC users use the same computer, can the individual save their project without the other user mistakenly deleting the project?
Yes, certainly. So in TRACC, we've got a backup restore function. So a backup will effectively do you a local backup as part of it. If you use different logins into the system, your project is not viewable by someone else. But again, if you wanted to, you can share your project. So here we've got share a project option, which means that now anyone else that was to log into this machine will be able to see that project. So you can keep it tied to your own user login, or you can share it, which then allow anyone else to use that and utilize that data within there. And we've got the backup restore function as well.
Thanks, Dan. Ryan, thank you for your question. So when using census population data, if a journey time contour only partly covers an output area, does the whole population of that area get included in the result, or does the output area need to be fully covered?
Great question. So let's load the census data up so I can show exactly how this works. So there's two ways in which people use census data. Sometimes people use OA centroids as the origin point. That ensures that every centroid has got a point within it. So there's two aspects to this question. One is where you might have multiple points within a census area. So if I click this area just here, I'll move this. So we'll see that this one has got 8 people aged between 11 and 15. 15 in there. And I'm just going to say, for argument's sake, there's 8 different origin points in there. What we will then do is split the population evenly amongst the amount of origin points that sit within it. So if we had 8 points in there, each one of these would be worth one person effectively. Now, there'll be some locations, because output areas are tiny, especially in city centres, where we might not have any population at all. So there's one just here. You can see we've got no origin point in there, but because it's in a very built-up urban area, we've got 16 people that live within it. So what TRACC will do in this instance to ensure it is counted in the result is it'll put a pseudo dummy origin point in the middle. And using that origin point, it will interpolate the travel time based on the closest origin points to it. So if this was 10 minutes, this was 11 minutes, it was right in the middle. It gave a journey time of 10.5 minutes as part of it. So that will be done. What you can do as part of that, actually, when we do our demographic report, we've got a dummy origin report. So what you can do is save that dummy origin file back out as a CSV file and load it back in and rerun your analysis. By rerunning that analysis, it will then generate an actual journey time and dummy points. So we can use that. The other thing we can do as well, as opposed to doing the even distribution of population, when the important origin file, I'll choose any file here. What we can do is you've got a weight factor. So address-based data, for example, might have one point and say this point represents 20 different locations, such as a block of flats. We can use that data here to say, actually, this location has got 20 times more weighting associated with it. And so when we distribute that population, more would go to that location just there. So yeah, we kind of do it that way of splitting the population evenly amongst the amount of points within the area. Output area is great because they're very, very detailed, but we have to have people use MSOAs, LSOAs, and so on. So yeah, we can do it kind of either way.
Lee, thanks for your question. So Dan, for the thematic contours, can you use meter or kilometer parameters instead of time bands?
If we do the result as distance based, we can do that. So when we do a calculation for any one of these modes, we can choose distance or time. If we choose distance, the result output would come as a meters as opposed to a time. We don't do it for public transport right yet because we use a straight line by default for things like trains and things like that, so we don't bring the distance across for public transport journeys. We do the time for that, but it is something we're looking at in the future. Also, when you export a walk run out of TRACC, go to reports, call it walk. We actually export for road only modes, both the distance and the time, which is now done. So here, these are all non-accessible because it's the whole area. But if I just choose one that's got a value here. So here we give an example for this location. We've got the distance in meters, and then we've got the time in minutes. So for road only modes, yeah, we do distance and time as part of it.
Thank you. Ringo, thanks for your question. How do we add or edit bus fare information within TRACC?
So at the moment, to load bus fares in, we can import fares using Netix or GTFS data. So we can import that data in just here, and we can export it out to them same formats. To actually do it in the system, I've actually never done this. My colleagues done it before, but let's give it a go. So on a service, we've got a fare function. What we can then do, I believe, is we can add single. Actually, I think I've done that right. Add it here. Ticket type, single. Three. And then what this will then do is create me a fare triangle as part of it. that looks like this. So now we've got, I'll trace a very long route, so I'm not going to go into it all. Stops and the pattern here, and then we can see effectively to travel from here to here. We can start putting in our fares manually as part of it. So we can say £2.50, £2.20, £2.30, and so on. We've actually got another webinar that was the new feature 2.1 that actually shows NetX data working natively as part of this. So what I can do is I can get Emma or Shireen to forward that on to you, and it shows in a bit more detail. But effectively, it'll populate all this here. We can then save it, and then it'll just show the information right now. Our next feature of TRACC coming later in the year will actually be giving, it's part of enhanced output, not just a journey time, but a journey cost. But I want to stress at the moment, the BODS data is only doing it for buses. We haven't got the national routing guide from National Rail data in there or anything like that. So that would need to be entered manually as part of it.
Thanks, Dan. Do we have any more questions? I won't end it just yet, just in case anybody is typing. But from all of us here at Basemap, we just wanted to thank you again for your time today, that you've given us your afternoon. Thank you, Ringo. And the webinar will be sent to you all over the next day or so. But if you do have any questions, please don't hesitate to reach out to us.